So this unit's going to pick up where the last unit left off. So the last unit, we talked about first derivative and we talked about second derivative and what those tests are for, increasing, decreasing, concavity, putting it together to be able to graph something without a graphing calculator. What this does now, beginning of this unit, is what happens to the word problems, the applications of calculus. The power of calculus is so tightly into physics, is this idea that there's a lot of calculus that's applied, where you get to apply the math. So, this unit, this question, this lesson has to do with maximum and minimum applications. Sometimes it's called optimization questions. So if you're asked for what value would give you the maximum profit, what value would be the least amount of material used, how does that relate mathematically? All of that language has to do with relative maximums and relative minimums. Do you now know how to find those, right, with calculus tools? So if you're asked a question to find the maximum profit, if that's the question, do you recognize that question is asking for a relative maximum? Yes. And that, do you know the tool you would use? The first derivative test, right? And see where the maximum is to be able to answer that question. Or the same thing. Sometimes you're asked for the least amount of material, right? Or the least amount of cost for something. Same thing. All right. This is going to be a two-lessoner. 5.1 and 5.2 is practicing reading these word problems and answering it, okay? So, one of the most common applications of calculus involves determining maximum or minimum value. Sometimes it's called optimization. Do you know what it means if you optimize something? Have you heard of that word before? All those great words you learned through vocabulary.com. Optimize. If you optimize, how about like Transformers? What's his name? Optimus Prime. Why is he called that? What does it mean if something is optimal? So optimal means it's the best situation, right? If it's optimal, it means it's the best. If you're optimizing something, it's either you're finding the best value you can. That could be the best maximum value or the best minimum value, whatever the context is, but it's the best, right? That is the number that would be the best, the most profit, the least cost, whatever that is. That's what it means to optimize something. All right. Here is a list that we will follow to a certain degree. So when you have a word problem, what are some things that we can do? So number one, it says, choose variables and draw a figure if something's not drawn for you. 2, write a primary equation. So isolate whatever is to be maximized. 3, rewrite with only one variable on each side. This may require a secondary equation. 4, find the domain. And then 5, take the derivative, find the critical numbers, the number line to be able to find you the local max or the local minimum. Let's practice. Nothing gets learned in like 30 seconds. It's all me setting it up for you and you practicing. Number 1, a box with no lid is to be made from 48 centimeters squared of material. If the box must have a square base, find the dimensions that produce a maximum volume. So I want us to annotate it just a little bit. So what is the shape? A box. It has no top to it, right? There's no lid. It's to be made of how much material? 48 centimeters squared. And the box has what kind of base? A square base. It says find the dimensions that produce a maximum volume. How can I connect volume to the word box? What will be the primary equation is what's the volume of a box. So we know volume is length times height, correct? Let's start with an equation we know that brings together what we're looking for. Volume, length, width, and height. All right. What do we know about this box? Do you see a box over here on the right side? The bottom is what shape? Square. That means that the length and width are what? So I'm going to let a variable represent that. And that variable will be the same variable because it's a square. So x represents both the length and the width, right? And then we have height of the box. So already in our equation, we don't have L and W. We now have what? And x times x is x squared. I want you to notice that for us to solve this, we need only one variable on the right side. It's okay we have a variable on the left, but we can't have more than one variable on the right in terms of taking the derivative and finding the local max or min. So sometimes there's more information given in the question that allows us to substitute in to get rid of that extra letter. So what have we not used yet that could help us? The material is what? 48 centimeters. So for a box, what would represent the material for the box is each face. In other words, the surface area. So what is the surface area of this box? The surface area is 48. Good. Using x's and h's, can you tell me the surface area of it? The bottom is what? A square. What's the area of a square? X times x, which is x squared. So that's the base. What's the shape of each face on the sides? Or is each rectangle the same size? Why? Because the base is a square. How would you describe the area of the rectangle? And how many rectangles do you have? I need to know that it wasn't magic, that you see where 4xh comes from. X times h is the area. And how many of those rectangles do you have? And then x squared is the area of the base. And altogether, what is the surface area that you're given? 48. How can I take that equation to get rid of the h in the primary equation? I'm going to get h by itself. So then I can plug into the other equation. So what algebra can I do to get h by itself? Keep working with me, please. How do I get h by itself? Instead of adding x squared, you can? Good. Subtract. How about that? Si se puedo, right? You like that? Thank you. Yeah, that's it. Me and some other guy. You had it first. So, all right, that's right. Siklali, right? And she said that too. But guess where she got it from? Oh, yeah, there you go. All right. Yeah. Okay. How do I get h by itself? Still. Divide by what? The more we can simplify something algebraically, the easier the calculus will be. What did I just say? The more you simplify something algebraically, the easier the calculus will be. So is h by itself now? Yes. Good. Can the left side be written in a nicer way so that the calculus would be easier? What should it look like? Any ideas? So I see that 4x belongs to both. Is that right? So 48 divided by 4 is 12 over x. And then x squared over x leaves you with x over what? 4. All right. We're going to plug this in, and we're going to do more algebra. So where there's an h, what did I plug in? Remember, this is what h equals. We agree, right? So can you see where there's an h, what we put in its place? I need you to distribute. Again, algebra before calculus. There's probably a saying there that I can't finish off before. But algebra before calculus makes the calculus easier. What would happen if I distributed? What's x squared times 12 over x? Now remember, x squared and x simplify, so you're just left with what? 12x. Can you see the algebra there? Where the x and the x squared, they divide, right? And leave you with an x in the numerator. What would happen if I went x squared times the second term? What would you get? You would get what? X cubed over 4. Do you now have one equation with one variable that we're trying to find what? What is our goal again? To find the maximum volume. That means, in calculus terms, what are you finding? The local maximum, right? How do you find a local maximum? What do you do to an equation? Take the derivative. Go for it. See, there gets a point where you go, I don't know how to take the derivative of 12x. Like you get to such a helpless feeling, right? That you know more, right? The derivative of 12x is? Right? Yeah. This is like a little bit, but not like silly, right? What's the derivative here? 3, I like. I like that. Over what? That's it. I know. What don't you like about that? What number don't you see here in front of x cubed? 1 over 4. If I go 3 times 1 over 4, what is it? 3 over 4. And then what do I do with the exponent? It's just basic power rule. And there's a silly fraction. Remember when I'm going to dress up for Halloween? Is there a reason you guys are like tireder than tired right now? Did something happen last night? You just didn't sleep well? You're okay? Because I look out and it feels like you're yawning. That your eyes are like not into this. Alright, I'm going to keep going forward. Next, what am I going to do?
Make it equal to 0.
You make my videos better when I look out at you and you give me energy and that it seems like you want to learn, you get it, and the whole bit. And don't you worry, I get what tired means. Okay? So don't think I know what exhausted means and what tired means. Alright, why do I make it equal to 0? It's to find the critical numbers. I also want to see if there's anything that makes it undefined. Is there any variables in the denominator that make it undefined? No. Okay, so solve for x. Don't make me work for you. Work with me. Not yet. Not yet.
I can't multiply.
Oh, come on. Most of the AP exam is no calculator. So, even though there's parts with and without. What would be a good first step here? You know what I'm going to do instead? Add 3x squared over 4 to the right side. Isn't that crazy? Algebra. Can you see what I did? Algebra to help me. Do you see? Do you see? Do you see? I added 3x squared over 4. Now, what can you do to get x by itself? Multiply by 4. That would be 12 times 4 is. Next, what would you do? And you get. Does 3 go into 48 evenly? I like that. Now you're starting to wake up. Maybe you're not feeling well. I don't know. Okay. That's what I'm asking about. Tennis? Did we beat Cat City? That's what I'm talking about. Those little kitty cats. Go, Lady Rajas. Yay! Okay. Does that wake you up yet? Try to be a teacher and look out at like dead faces. It's not fun. Now, why am I only going to write down the answer to be positive for? I know you're smart enough to realize you're solving a quadratic, the answer is positive and negative, but why am I only going to write down positive for? Because there is a domain restriction for this question, right? Domain is what numbers can you put in for x. We know we can't have negative numbers, right? That's a domain. One of those steps was find the domain. Domain has to be positive, right? Sometimes there's even more restrictions than that, but we know it has to be positive, so we're not using negative 4. What do I do next? Now you're starting to wake up. You should watch this video back again and just picture yourself being all dead-faced while I'm trying to teach you. Or yawny, or watery-eyed and stuff. So what number am I going to put on there? How many times do I act exhausted to you? When in my heart, I am so exhausted sometimes. Right? Do I act that way? No. You've known me for 1.5 years, and how many days do I bring it? Never. I never bring it? Oh my God, that just hurt my heart right there. You meant the other way, right? That every day I bring it, right? I never show I'm tired or grumpy or any of that. And sometimes I feel tired. And sometimes I feel grumpy because I'm human. So, technically it doesn't go all the way to the left, does it? We just talked about this. 0. And we don't really have any information to know what the right end, what that would be at this point. What am I going to do next?
Plug in the numbers.
What? Where? How? Okay, do you remember what the derivative right here?
Yes.
So what number are we going to plug in? No. 1. Okay, so plug in 1. Is the answer positive or negative? What does that mean? What's happening to the function from 0 to 4? It's increasing. So 1, 2, the answer is bigger than when you plug in 1. 3, when you plug in 3, the answer is bigger than when you plugged in 2. When you plug in 4, the answer you get is bigger than when you plugged in 3 or 2 or 1, correct? Right. And then what happens after 4? Well, I got to plug in a number. What's a number you could plug in? Like a billion? So, if you plug in that, what's happening? A trillion. I don't care. What's the answer on the other side? So what's happening at 4? Is that important to our question? Yes. Okay. What's our question again? So what did we just find? We found x. So the dimensions would be what? So the dimensions that maximize the what? Or is it dimension, not plural? Because it's dimensions? Dimensions that maximize is our, what word should I put down? The dimensions that maximize the volume are, let's go with that. What would that be? X is what again? What unit? Is it squared? No. Because it's just a side length. And what's the other side length? 4, because it's a square. And what don't we know that we need to figure out? Any idea how we can find the height? Do we have an equation? What number should I plug in for x? So when you plug in 4, I'll do that here on the side. That is going to be 12 divided by 4, subtract 4 divided by 4. That's 3, take away 1, which is 2. So what dimensions would maximize that box? 2. Take out your calculator. If you ever have a dead calculator at the beginning of class, you need to plug it into my charging dock right at the beginning so it has power.
I want to let you know that on the test, I spent 40% of my time.
I understand.
What are we going to plug in?
So, this is what we're going to plug in. We're going to plug in the volume equation. Now remember, the volume equation was x, well, it's 12x, sorry, I'll do that one, was 12x subtract x cubed over, can you see that? There you go. It was 12x subtract remember how to do a fraction? It's control and the divide sign. I figure if every day we use your calculator a little bit, it'll get better, right? X cubed and then that's over 4. So 12x minus, is that right? Yeah. So if I press enter, it's going to give me a function, right? It'll graph it. What's the problem with the graph right now? We have to zoom out, right? To be able to see it. So if I go to, let's hope I do this right, menu, and after you press menu, press window and zoom. Zoom out is what number? So if I keep pressing,
There's a window too.
so if I keep pressing enter, it keeps zooming out. Can you see that? I can press escape to get rid of it. I know there's a shine on it. Here it is. Do you get that? Now, do I care about the second, third, or fourth quadrant? So the domain restriction is all in the first quadrant, right? So if I want to see that it goes from 0, I could figure out that other restriction on the right side. Where's that local maximum? Can you see it? Okay, find the local maximum with your calculator. Good job, Jose Angel. You're the man. So I'm going to go to menu. I'm going to go to analyze graph, and I'm going to go to maximum. I'm going to move it to the left. It's always left than right. So I'm going to move it to the left. I don't know what I did. There it is. So let me do it again. I'm going to go menu, analyze, and maximum. So, and you can like be gentle with the pad, right? Move it left then right. And what does it tell you? Now, what does it also tell you? The x-coordinate tells you the side length of the base, right? What is the y-coordinate just gave you? The maximum volume. Now, notice in the question, it didn't ask, what is the actual volume? Could we have done that? 4 times 4 times 2? Does it match? But they're on a graph, right? Let's say in an AP exam, they won't give you a beautiful equation, right? They're going to give you the ugliest one you've ever seen that you have to type into the calculator and still do this work that by hand you couldn't really do it and never would want to do it. It's so ugly looking that you want to do it on the calculator, and that even if it's as ugly as can be, you can type it in and still be able to analyze it, right? And what you're looking at. I'm listening. Is it out? I might have another box in the cupboard by the fire extinguisher. All right. Can we read number 2 together? Is it okay if we try to keep practicing with our calculator?
Yeah.
Okay, let's read number 2 together. We got it? Hey, what you don't practice, you'll never get, right? You have to practice regularly to feel good with your calculator. All right, let's read this together. We're going to annotate it together. The product. That seems like an important word. The product of 2 positive numbers is 288. Find the 2 numbers so that the sum of twice the first plus the second is as small as possible. So what's the indicator to know it's an optimization question? Small as possible, right? And if you think of it in terms of a graph, what you're finding is the relative, but within my domain restriction, right? Because real problems often have a domain. In this case, the numbers have to be what? Positive. So that's a restriction, right? On it. So in order to do this, I need an equation. Any idea what that equation is going to be? So it says the product of 2 positive numbers. Let's say that x is one number. I'll call that the first number. Why not? And y is going to be the second number. Is that okay? Those are our best friends in algebra, right? X and y. So what it said was the product of two numbers is what? That's from the first sentence, correct? What's the second sentence? Find the two numbers so that the sum of twice the first plus the second is as small as possible. Now, what is the indicator to know the second equation is actually my primary? What does that mean, primary? It's the one that you're eventually going to take the derivative of, right? Make equal to 0, work with. That the actual question you're looking for is connected to that sentence, right? Like, what does the question ask? Find the two numbers so that the sum of twice the first plus the second is as small as possible. Which is the primary connected to the actual question, right? So, the sum means what? Adding. What are we adding? Okay, x is my first number, so twice the first would be plus the second, and we want that as small as possible. You could label this equation whatever you want. So I'm just going to label it, what we have, find the two, the sum, right? So I'm going to label it S. That's an S. There's my primary equation. Now, how many variables do I have? And if I rearrange it, I can make the variables on the other side. But no, how many variables do I have here? That's too many. So how can I use this equation to reduce the number of variables? And does it ultimately matter which one you eliminate? No.
You can make it equal to y
Or x. This means either you're looking for the second or first one first, right? And go back to find the other one. So it doesn't really matter. So let's say we go y equals 288 over x. If I do that, I got y by itself, correct? That means when I go into the primary equation, where there's a y, what will I put in? And I'm going to make it fun. Instead of over x, I'm going to go x to the negative 1. And I want you to think, why would Gertson do that? Why is he causing pain? Because when you take the derivative, right, we need it in exponential form, which means the indicator is what do we need to do next to find the minimum value? Take the derivative and make it equal to, can you do that? So if I take the derivative of this equation, what would you get? 2, and then? I love it. Equal to? 0. All right, this is what we're going to do. You are first going to do it by hand, and then we're going to use our calculator and see if we did it right. And I'm going to practice solving an equation with the calculator. Is that okay? Remember the two things I said that make a good student, right? It's not the ability. Persevere and believe, right? Like you're at Disneyland?
Yeah.
They're all into believing there, right? Believe that there'll be snow coming down, and then suddenly there's snow that comes down. Can you solve this?
Yes.
Si se puede, right?
Si puede.
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 Si se puede.
Yeah.
That's what I said.
Nice.
It's just my Canadian accent in Spanish. It throws you off. Solve it. Then once you solve it, can you type it into your calculator and see what's the answer the calculator gives you? Do you give up? Do you persevere and believe in yourself?
I'm just gonna get do it.
Don't you turn it into a fraction and then you simplify the fractions with the 1?
Oh, that's interesting. Let's see what Gertson does.
Why did you do that? Oh, you did that so well.
Dang it. What did I do?
That's what I was thinking. You put 2 on the other side.
I added 288x, then I went, wait a second, I'm not doing calculus anymore, so this x to the negative 2 is not like helping me out any, right? So let's go back to algebra. Let's make that a positive exponent, right? So make that into x squared on the bottom. what did I do? Instead of negative 288, what did I do? I added it. Why is x squared on the bottom of the fraction? Because x to the negative 2 means that, right? Do negative exponents help you in algebra solve anything better? No, right? It helps you in calculus. Now what would you do to both sides?
Multiply by x squared.
Can you keep going from there?
Yeah.
Keep going then. Then use your calculator. Because I told you to. Because we don't practice, we won't be comfortable, we won't be able to do it. Many times in calculus, they just want you to be able to solve it with your calculator. And if you have to, you round it to 3 decimal places. And can you?
You can't divide it.
I can't divide 2 into that? And what does x equal? Why not negative 12? Okay, how would you use your calculator to solve it? So, you can press this little shaky calculator thing, and it goes back and forth between graphing and be able to just type something in. See the shaky little calculator thing? Press that back and forth, and it goes back and forth between graphing and what you want to type in. If I go to menu, what do you think I'm going to go to? Algebra. I'm just solving an equation. And where does it say to solve? What button? So press 1, and then what am I going to type in? What equation was I trying to solve? 2x. No, it wasn't 2x, was it? It was 2 minus. The derivative is 2 subtract 288 x to the exponent, what? Negative 1. Move the cursor down. Equals what? See, then you get comfortable. Where's the equal sign, right? And all that. Like, it only gets comfortable as you practice. And then, to solve an equation, you have to go comma. Do you know where the comma is? It's on the bottom left. Right there. It's not an apostrophe. So, comma x. And what the comma x tells the calculator means to solve for x.
It's negative 2, the exponent.
Is it? Did I type it in wrong? You're right. Thank you. That's okay. And then equal sign. Exactly. Where's the equal sign? Actually, at the end, you're not going to press equals. You're actually going to press answer, which is on the right side in the middle. And then what answer does it give you? Negative 12 or positive 12. We know enough that the question said positive numbers only. When we practice, we'll get this, right? Do you know you're not taking the AP exam next week? You know it's May 15th.
What did you say to put x? Wait, why did you say to do that?
Because this calculator has its own language. And the language of this calculator is the comma tells it to solve for that variable. Which means you could have more than one variable in an equation, go comma, and it would solve for whatever variable that you wanted to. Okay? Okay. We're not done yet. What do we have to do? Well, first, what do we have to do before we find y? And we know that this is 0, because it has to be positive. What am I testing for? If you don't test it, you don't know what you came up with as a maximum or a minimum. There may be no solution for your question. You got to know. So if you plugged in positive 1, would that give you a, this is the one we're plugging into. Will it give me a positive or negative answer? Remember, that means the same as 2 subtract 288 over x squared. So if I plugged in positive 1, the answer is negative. Believe me, you can't do that mentally. That's 2 subtract 288. If I plugged in a number bigger than 12, like a billion or a trillion, notice that this fraction gets huge in terms of being like the denominator. Means that that fraction gets closer and closer to 0. It becomes very small, the bigger number you plug in. So 2 subtract a really small number is going to be positive, right? Because this fraction, 288 over, is going to become very small in size. All right, what did that tell me? So we proved it, right? That 12 creates a minimum, decreasing to increasing. So what should the two numbers be? One is 12, what should the other one be? Right? And you said that's 24? And you found the two numbers. So it says find the two numbers, right? And you can write a simple sentence. So this lesson is going to get more involved the next time when we do 5-2, but it's the same type of lesson. Read. You have to generate the equation. It's not going to be given for you. Take the derivative equal to 0, make sure it's a maximum or minimum, right, and put it together. How do we learn this? Is by practicing. Are you going to learn just me doing it for you? No, right? It's going to be done in 20 minutes? No, it's going to be, you're going to put some work into it. So, turn the page. I want you to start the assignment.